about these three special products. We may not be able to get to this, but just keep it in mind. These are my initials, and this is what they gave me as my account. So anyone remembers what this refers to and what this refers to, and the other one? So these are in the so-called first day agreement. Let me know if it's blurry. Let me know if you can't see. Let me know anything that you need. And I'm just going to type. I'm sorry, I'm going to tape this like one more time here. Yes. Anyone remembers what these mean? And what are they for and how to use them? What is this called, first of all? It's okay if you're wrong. I just would like to have communication and interaction, please. How is this called?
Wasn't it for like the combining like terms or something like that?
Binomial. This is a binomial. A plus B or A minus B, two terms, a binomial. So this is a binomial squared. This is another binomial squared. Anyone remembers how many terms when we obtain when we square binomial? Result is a
Trinomial?
excellent. It is a trinomial. Excellent. So if you remember, A plus B times A plus B is the same with A plus B squared. Do you agree with that?
Yes.
Everybody?
Yes, I agree as well.
Perfect. So how do I perform this operation? Well, A times A, I distribute, right? So this is A squared plus A times B, this is AB, plus B times A, which is another AB, and plus B times B, which is B squared. And this happens, these two happen to be like terms. So this is 2AB. So that's how we get the trinomial. So the answer is A squared plus 2AB plus B squared. I want to review this and establish this from the very beginning because I don't want to, can we go back to it? Anytime, of course. But we shouldn't get stuck on some little algebra moving forward. So now what happens if I have minus here? I thought this would be different, but it's not. So what happens if I have minus here? What will be the only change? Anyone, please?
Addition would change to subtraction.
Which one? There are three terms.
So it would be A squared minus 2AB.
Indeed, indeed. So that's the only difference. That's the only difference. So here's an example now. Let's say 2A plus 3B, everything squared. You can say FOIL it. No, not anymore. This is beginning algebra. And we are in calculus. So we have to be able to complete this quickly. So remember, this is the first term squared plus twice times the first times the second, first term times the second term, plus the second term squared. Is this clear what I just said, what I just wrote here? So this is the first term, this is the second term. So how do I quickly remember the formula or the special product? First term squared plus twice times the first times the second and plus the second term squared. Do we understand this step? Do we understand? Do we see the pattern?
Yes.
Yeah.
Can anyone help us write these three terms here? We have to square the first term. Can anyone give us the first term squared? No one can square 2a. I refuse to believe that.
2a squared.
Which is?
Before a squared.
Good. Plus 2 times the first times the second. Multiply these two and multiply by 2. What do we get?
May you say that again? I'm sorry.
We multiply the first term and the second term, and then the result gets multiplied by 2. I'm following the pattern. Multiply these two and then multiply by 2.
Is it
12 AB.
Excellent. Plus, I'm following the pattern. The second term squared.
is it 9? 9.
9B.
To the second.
Very good. So when we multiply 2a or square by multiply 2a by 2a or square this is we get 4a squared. When we multiply 3b or square 3b squared, we get 9b squared. Is this okay? Any questions?
Yes.
Perfect.
No.
Good. Can anyone give us an example with a negative so we can work on it quickly? Okay, 5x minus 3. Can anyone give us the answer quickly using the pattern? If you're still foiling, then you need to practice the pattern.
It'll be 25x squared minus. So would you still do the first term times the second term?
The pattern is the same. First times the second multiplied by 2.
So 30.
Very
X.
good. The last term is always positive, correct?
And it would be 9.
That's it. Very good. So finally, the last formula, this is the difference of squares. Difference of squares. So this is different. So a plus b times a minus b. Let's FOIL it the first time and the last time, I hope. A times a times negative b, a times b, or b times a, plus, I'm sorry, I meant to write minus, a positive b times negative, it's negative b squared. Good. What happens now in the difference of squares? What do you notice? Anyone? What do you
There's
notice?
4 terms.
Very good. So a squared minus b squared. So what is the pattern here? First term plus the second term multiplied by the first term minus the second term. Can anyone give us the pattern? What is the pattern that I will remember forever?
First term squared minus second term
Excellent. Excellent. Thank you so much. As an example, 2x minus 1 and 2x plus 1. Can anyone use the pattern and tell us this is it? Anyone, please?
Will we still have to break it down solving using FOIL?
Not anymore. We're not in beginning algebra anymore. We are in calculus. Is it wrong to FOIL? No. But we are not going to be able to move on if this is an issue. We want to move on and move on fast. It's a lot of material that we need to cover. So can anyone follow the pattern and tell us what it is?
Two x squared minus 1 squared, or 1.
Well, how much is 2x squared?
Oh.
So that would be 4x minus 2. Sorry, plus 2.
We're following the pattern. We have to square this. We have to subtract when we square this.
Would it be 4x squared minus 1?
That's it. 4x squared minus 1. Do you think we need more examples, or can we move on to something else?
One more.
Of which type? Of which type?
Well, actually, no, I'm clear on it. I'm sorry.
That's okay. That's okay. Good. The other thing that I wanted to address tonight is graphing a piecewise defined function. This is an algebra situation. Everything is algebra. We haven't even started anything yet. But this is a very important issue in calculus. What is a piecewise defined function? So here's an example with two branches. Let's say 2x plus 4 for x less than or equal to 1, and negative 3x for x greater than 1. This is a piecewise defined function, meaning it's defined in two pieces. One piece is valid only for numbers from negative infinity to 1. Anyone remembers how to write the interval notation for this? This in interval notation. Can anyone give us the interval notation for x less than or equal to 1? Anyone, please?
Positive infinity to 1 or negative infinity to 1.
Yes, negative infinity to 1 with a bracket. Excellent. Why a bracket? Because of the equal symbol. Perfect. Awesome. Thank you. Can anyone give us the interval notation for this?
That would be parenthesis negative infinity, comma 1 with another parenthesis.
We already have negative infinity. We can't go back.
1 to positive infinity.
Yes, 1 to positive infinity. Great job. Every time I'm asked to graph, the first thing I have to think is domain. This is the key. It's the starting point. Then I will create a table, and I will put the domain in there. Can anyone read from here the domain of this function from here? What will you say? The domain is?
All real numbers.
Brilliant. Thank you. All real numbers. So the domain is negative infinity to infinity. Nothing is missing. Everything to the left of 1, including 1, and everything to the right of 1, not including 1, but 1 is here. Excellent. So this is a domain that I have to put in the table. Okay. Now, one number has to be in the table at all times, and that number is 0. I shouldn't say that at all times, because what if the function is only defined from 1 to infinity? Then 0 doesn't belong in there. But if the domain is all real numbers, 0 has to be there. Also, the other important number is 1. Why is 1 so important? Because something changes at 1. What changes? This function goes from this graph, from this function to this function. So this must be a threshold, something important. Notice that at 1, there is a bracket opening to the left, and there is a parenthesis opening to the right. I'm going to write or copy these symbols right under 1, not to the left or to the right of 1. Right under 1, I have the bracket, and I have the parenthesis. Exactly under 1, I have these two symbols. The next step is I will make myself a note. You can say this is an overkill. You have it here. True. It's an overkill, but that's fine. Bear with me. From negative infinity to 1, I have to use this function, 2x plus 4. From 1 to infinity, I have to use this function. Now let's see what happens. Next, I have to plot points. I have to determine some ordered pairs. But because this is what type of function and this is what type of function, what type of functions are these? Can anyone tell us they are such and such? What functions? Anyone will give it a shot? What type of functions are these? No one remembers what 2x plus 4 or negative 3x is. Is it logarithmic? Is it exponential? Is it quadratic? Is it absolute value? What type of functions? Rational? What type of functions are these? Anyone?
Exponential?
They are linear functions. Exponential function looks like this. The variable is the exponent. So they are linear functions. For linear functions, how many points we need to graph? Anyone, please?
2.
Exactly 2. Excellent. So I plug in 0 and I get 4. I plug in 1 and I get 6. If I plug in negative 2 because I want both x and y intercepts because they exist, negative 2, negative 4 plus 4 is 0. On the other side, I plug in 1. I get negative 3 right inside the parenthesis. And you can say, no, you cannot plug in 1 here. I agree. I cannot. Because 1 is here. 1 is not here. But I'll show you why I do plug in 1 in negative 3x. And let's say another one too, it's negative 6. I'm finally ready to graph this function. Here it is. And after this, we'll stop, I promise. Okay, so negative 2 for x, 0 for y. No problem. 0 for x, 4 for y. No problem. 1 for x, 6 for y. No problem. Full point because of the bracket. So this is a full point. I know it's a line. It's done. On the other side, I have 1, negative 3. But it's an open point. Why is it an open point? Because I was not allowed to evaluate negative 3x at 1. I did it anyway, but I have to leave it open. And then 2, comma negative 6. And here it is. You do not have to graph these functions using 2 different colors. The reason I did it is because I want you to understand that this is a piece and this is another piece. If you graph them like this, by the vertical line test, this is not a function. But this one stops at 1, and this one starts at 1. By the vertical line test, this is a function. This is one of the topics that it's extremely simple, I think, but students have difficulties understanding this. And a lot of students graph this. It's not possible. You cannot extend this function. This function is only between negative infinity and 1. That's why I put it here. And this function is only between 1 and infinity. That's why I use 2 different colors so you understand they cannot overlap. Can anyone, and we stop right there. Can anyone identify the range of this function? Can anyone identify the range of this function? As you see, the domain is everything from negative infinity to infinity. What about the range? From negative infinity?
Negative 2 to.
From negative infinity till? From negative infinity till?
To 6.
That's it.